science fans, I'm Mrs. Corbett. Welcome to Null Academy Science. Obviously, not ideal. We'd like to have you in here so that you can have a go at some of the science yourself. But I'm going to take you through an experiment we would perhaps do with Year 7, and maybe you can take part at home. It's something simple that you can do with items that you have in your house, and it's quite a good lot of fun. So let's get cracking. Now, I'm sure most of you have come or heard of the term acid. So in Year 7, you would do a whole module about acids and alkalis, and you would learn about acids and alkalis all the way through. So if you did A level, you would learn about acids and alkalis as well. So we start off in Year 7 looking at the basics of acids and alkalis. Now, I'm certain you've all heard of an acid, but you may not have heard of an alkali. So let's start with acids. So an acid is a species or a type of chemical with a low pH, and it has certain properties. Some acids are very dangerous, some acids very mild. So you put acid potentially on your chips. Vinegar is a really good example of an acid. It's called ethanoic acid. You've got acid inside your body right now. Hydrochloric acid in your stomach, and it has two jobs. It kills bacteria and microorganisms, but also it helps the conditions to digest your food. And that's quite a strong acid, which is why if you ever taste it when you're sick, it's horrible. Most people believe that acids are more dangerous than alkalis, but that's not technically true. So let's look at the other end of the spectrum. We've got something called alkalis. Now, alkalis are opposite, essentially, to acids. They have a high pH. Now, pH of water is 7. Okay, so water we drink has a pH of 7, and the scale for measuring if something is very acidic or very alkaline is called the pH scale, and it goes from 1 to 14. So acids are 1 to 6.9. And alkalis are 7.1 up to 14. So 14 would be a very strong alkali, and 1 would be a very, very strong acid, or even 0. You get some acids that have a value of 0. They're so strong. Now, as scientists, we can't work out whether something is an acid or an alkali by tasting it. That's literally rule number 1 of science: is don't lick anything, don't taste things. Now this, look at this, just looks like water, doesn't it? This also looks like water. I mean, I know what they are because they're labelled. But in science, you wouldn't want to say, oh, I think that's an acid, let's give it a lick, because you could corrode, and that's not very nice. And you'd probably be surprised how many acids and alkalis you have in your house. So what we're going to do today is we're going to make something that will tell us whether this is an acid, an alkali, or water. And in science, we have lots of different ones of these, and they're called indicators. So today, using something that is quite obtainable in your house, you might already have it in your house, if not easily sourced, we are going to make a simple indicator so you can determine whether things are acids, alkali, or neutral, like water in the middle. Let's go. I've got my goggles on. You probably won't need goggles at home, although if you want to wear swimming goggles, this would be funnier. I've got goggles on because I'm just going to show you some quite corrosive acids and alkalis first, but the bit we do at home is perfectly safe. It's just like cooking, really, because one example where I've got 3 beakers and I don't know what any of these chemicals are. I could give them a little waft. They all smell of nothing. They smell and look like water. So in this situation, this is dangerous. We would need a chemical to identify or indicate whether we had an acid or an alkali. Just so happens I have one here. This is called universal indicator. And so I'm going to pop this in here and see what happens. Well, that's red. One in here, or pink maybe. Green. Orange. Let's have a little bit more in this one. Ooh. Blue. This one should be green. This should be pure water. It's not. So what this tells me is I've got 3 chemicals here. They're quite beautiful. This one is acidic and quite a strong acid at that. This one has a low pH, so a pH of around 1. This is a sort of yellowy colour. So this one is a weak acid. And this one here is a purple, blue purple, so this is a strong alkali. Now obviously if I was to mix any of these chemicals together, it could change whether they are an acid or alkali. So none of these I should drink. All dangerous, and I've used my indicator to tell me that. Just gonna see if I can affect this in any way. Oh. That's some good chemistry for you. Bit more. So we've now got like a beautiful bluey green colour. See what happens if I whack this in there. Oh, that just diluted it, I think. But still, fun. So now I'm going to show you how you make your very own indicator, and you can test some objects in your own home, some substances in your own home, to see if they change the colour of the indicator or not. They don't always go red for acids, they don't always go blue, it depends on the type of indicator. So the indicator we are going to make is made of this. It's not made of tinfoil, it's what's in the tinfoil that matters. Red cabbage is a brilliant, brilliant indicator. So if you've got some red cabbage at home, grab some. If you haven't got any red cabbage at home, stick it on the shopping list for next time. So I've got my red cabbage, so all I'm going to do is try and slice it into small pieces. Goodness, that is what is going to make our indicator. So what we're going to do with that is we are going to pop it into a pestle and mortar. If you don't have a pestle and mortar, you just need to put it somewhere in a bowl or something that's not going to break, and find something that you can bash it with and grind it with. You might even be able to whiz it up in a food processor, I should think. So you're going to give it a bit of a bashing. I'm going to add some water. And you're going to bash. Right, I think I've made a suitable enough mess there. So what I'm going to do now is we're going to filter it. So now I've ground up my cabbage. Lovely. It's got lovely liquid in it. I'm going to filter it. Now I am using some filter paper and a funnel. Now I'm aware that you probably may not have a filter paper and funnel in your house. So what you could use is... So I've got my filter paper. Ooh, really broke it. I've got my filter paper and funnel here. What you could use is a tea towel or some muslin, and just pop it in and squeeze out as much liquid as you can. Don't use kitchen towel because it will absorb all the moisture, and we want the moisture. So yeah, I'm just gonna pop that in there and let that start running through. Can you see the liquid is running through? That is going to be my indicator. There it goes. But again, tea towel and squeeze works just as well. Sorry if you've made as much mess as I did doing this, but I now have quite a decent little amount of indicator to use there. So let's try it with some substances and see what colour it goes. Where most of you probably don't have test tubes and you don't have pipettes and things. So I'm going to use a pipette, but you could also always use just a spoon or a straw to get the indicator out of here and into a smaller container of some kind, maybe like milk lids and stuff. So this is my indicator, and I'm just going to show you with the same acid. So I'm going to get my other indicator that I used to show you. So that's green in the middle, so that is our neutral, that's water. And then I'm going to pop in some of my acid, which we remember went pink in there. I'm going to pop some into my homemade indicator and see what happens. Oh, look at that. Beautiful pink colour. This has gone more of an orangey colour, but beautiful pink colour. Let's try my alkali. Oh, it's got a nice blue colour if you remember in the indicator. Let's see what happens if I put it in our homemade indicator. Ooh, look at that. Absolutely beautiful. So we've got here a really nice spectrum. So if it's more to the pinky side of things, we know that we have got an acid, and if it goes green, then we know that we have got an alkali, and then water will remain this lovely blue colour in the middle. So that's how you make your own indicator at home. You can test anything you want to at home with this. You could go into the fridge and have a look at some milk. I've got a bit of soap here, just see what happens when I put some soap in here. Just made it bubbly, really. Yeah, can you see that's going slightly pinker? So slightly acidic, that soap that I've got there. It's actually a blue soap. Gonna need some more indicator in there. I've just turned it to bubbles. Yeah, it's gone a lot paler. Oh, I've breached some pink. You could try this at home on loads of different substances. You could try it on lemonade, orange juice, squash, shower gel, vinegars, cleaning products. If you have a go at home and you make yourself an acid or alkali indicator, or you do any work related to this, please feel free to send it in to Noel Academy. We'd love to see it. Love to get some house points in early if you're joining us in year 7. You can also catch us on Instagram. I am at Mrs_Corbett_science on Instagram, so give us a follow. And we also have a Noel Academy YouTube channel as well as a science one. So we are Noel Science on YouTube. Let's have a little bit of fun with some indicator now, shall we? It's fun to have fun in science, so I'm going to do something called rainbow fizz, which is where you take an acid and an alkali and you react them together to make a neutral solution using an indicator. Now, the alkali that I'm going to use is called sodium carbonate, and anything with carbonate in, if you neutralise it, it's going to release carbon dioxide. Fizziness, so when you have a carbonated drink like Coca-Cola, it's the fizziness when you undo. So that's what we're going to do. You can see there it started to fizz. Let me get my focusing. You can see it start to fizz. So we've still got our nice pink where it has mixed in with the indicator, and then it goes up to this lovely purple colour. What I'm going to do now, I'm just going to whack a bit of hydrochloric acid in the top there, so we should get a little bit of a fizziness, but also we should get a redness. Fizziness, a little bit of pink there, and now we're starting to neutralise. Just going to let a little bit out the bottom so you can see. Go all the way here, we've got our pink and our yellow to green. Might have gone a little bit too far on that one. Look at that, they've really well mixed. But look at that fizzy rainbow we've created, ideal for the moment in this time of celebrating NHS heroes with our rainbows.